Every so often, I see quite a few comments. Why are you not using Linux? DevOps engineers should only use Linux. Why Windows? Why are you always running things in containers? And when you do a bit of research, you'll find that around 90% of the internet runs on Linux. The cloud is made up mostly of Linux servers. Docker is designed for Linux. Containerization is actually a core Linux feature. Even Kubernetes run mainly in support for Linux containers. So that's a great question. Why not use Linux? Now today I'll be demystifying why I've been using Windows as a DevOps engineer, and hopefully there are a lot of tiny nuggets of information you can take away from this video. Whether you're a Linux user, a Mac user, or a Windows user, there are a number of reasons for my different choices on operating systems, so without further ado, let's go. Now the first and major reason I run Windows is for portability. What do I mean by portability? Portability has nothing to do with Windows. So what do I mean by portability? Now if you take a look at my Docker development YouTube series, which is my GitHub repo for all my tutorials, I start most of my tutorials with a Docker command. So for example, if you take a look at my Go folder under introduction and my readme, you'll see in my introduction to Go that I start with running Docker. I have a Docker file where I specify the version of Go I want, and then I start by saying Docker build and Docker run. I mount my source code in and I have access to Go. I do the same in my Python series, my C# videos, as well as Node.js. Even more complicated guides like my Redis guide. In my Redis tutorial, I also start with running Docker command. This means I get high portability because I run everything in containers. The same container that I'll run on my machine is the same container that you'll be running on your machine. So the file system will be more similar, which means that it does not matter whether I run Windows or Linux. So talking about portability brings me to my next point, which is containers. Ever since Docker and Kubernetes became really popular around 2015, my main goal was to run absolutely everything I could inside of containers. Now there's a big reason for this. To understand this, you have to understand the history. I was fortunate enough that before my DevOps career, I used to work as a software developer, writing code, and I was also working in the operations side, so deploying code and monitoring servers. So I worked on physical servers in server rooms. I've spent many years writing code, which means I've been through the full cycle from writing code, building it, testing it, deploying it, and then monitoring it, to the full feedback cycle. And later in my career, I started moving these things to the cloud. So working in operations and working with servers taught me the pain of managing servers. When you have a bunch of servers for dev and a bunch of servers for prod and you have to maintain these, you can never keep them the same. No matter how hard you try, running the same scripts on both dev and production, you never get identical outcomes. And if you've worked in that area in the past and you understand the fundamentals about why containers exist, it actually makes you excited, because being burnt by all these servers that are never the same and your scripts that don't always work on the same servers, when you run your scripts inside containers, the outcome is almost identical because the file system is the same inside the container. So containerization helps eliminate a lot more variables. It also means my dependencies inside the container would be the same dependencies that I have in dev as well as prod. So there's a lot less chances for my servers to become different. Containerization basically meant that we did not really need to care about how the server was configured. All we needed from a server is a CPU, memory, and storage. All the dependencies and scripts and all those other things and things you try to make the servers the same doesn't matter anymore. So containers help me keep dev and prod infrastructure similar. Now there was a similar excitement for my software development career. Software developers can relate to this. When you're a programmer, you have a lot of tools installed on your local machine. Different runtimes, different SDKs, different IDE versions, debuggers, and so forth. You have every version of C#, Python and Go installed on your machine. So what happens is your machine becomes a snowflake. Every bit of code will always work on your machine. Soon as you ship it to dev or production, you start getting failures because the environment is not the same. Now for me, containers made me excited, and because it drastically changes that. Ever since containers, I've decided to depart the traditional .NET and move all my learning to .NET Core. Because containers are so easy to run, it actually made me embrace other programming languages more. So I started learning Go and Node.js, as well as Python. Because I understand the operational side, I did not want to install all these dependencies on my machine. So even up to now, I purely rely on containers for my development environment. And as a developer, I can still do everything like get IntelliSense in my IDE. I can debug by attaching debuggers to the container. So I simply mount my Git repo into the container, and then I use VS Code to do the development. So that takes me back to my Docker development guide. If you take a look at any of my tutorials, like my Python introduction, and you take a look at my README, it always starts with running Python in Docker. And the thing that I do is I mount the working directory into a folder inside the container. So that means all my local files get mounted inside the container, and then I get a terminal because I run my Docker container with SH. So I get a terminal in the container, which means I have access to the full Python programming language. If you're a programmer and you're interested on how to debug Docker containers, I have videos on that as well. This meant that my machine is kept really clean because I don't have anything installed. And it also means that my code is highly portable, because if you have Docker, all you need to do is Docker build and Docker run, and you'll get the same outcome. And it really helps. If I want to rebuild my machine, I don't need to reinstall everything. All I need is Docker and the source code of my application, and I don't have to install anything else on my machine. So what does Docker containers and portability have to do with the OS that I use? Firstly, containers have decoupled me from the OS that I rely on, since I only rely on containers. And this is not just for development. If I'm an operations person and I need something like a WordPress site, I don't need to spend weeks setting up my machine, installing so many different dependencies of Apache, and trying to get PHP working in a Windows environment, or in a Linux environment for that matter. Sometimes open source solutions simply don't work on specific operating systems, but now I can just say Docker run WordPress. And here's a tip: if you're into DevOps, containers will help you learn a lot faster. There was a lot of technologies in the past that I wouldn't have learned because the setup takes so long. DevOps engineers rely on a lot of software and open source tooling. Open source tooling can be a real pain to install, especially as some open source tools require you to build from source. So they expect you to have something like Debian running. If you look at some of my guides like Kafka, Redis, and RabbitMQ, some of them are easy to run and set up, but some of these technologies can have an absolutely huge barrier to entry. If you have to configure everything and set it up, you might spend days or weeks before you can even get it to work. The whole point of DevOps is to get access to tools easily and quickly, and Docker adds a lot of agility because it removes all the setup problems. And if you ever need to set these things up manually without Docker, you can reference a Docker file, because a Docker file tells you exactly what dependencies have been installed.
It's the dawn of a new era. IT scientists have developed a new way to build and run software in groundbreaking technology called containers. IT engineers are assembling under a new banner called DevOps and are moving containers to something that's called the cloud.
And here's another story. When Linux containers became really popular around 2015, I actually moved from Windows to Linux because I wanted to learn everything there was to learn about Linux. That was my goal. And it was purely driven because containers was a Linux concept and it wasn't mature at the time. So running Docker on Windows was really difficult. You needed to run virtual machines on top of Hyper-V and custom solutions using VirtualBox. It was painful at first. This is because Linux containers are simply features that are built on top of the Linux kernel, which is missing in other operating systems. So how did I learn containers? I still believe that the best way to learn containers is to have a goal to run absolutely everything inside of a Linux container. Now, being fascinated with containers, I watched a lot of videos from DockerCon and came across a couple of talks from Jessie Frizzell, and these talks were all about running containers on the desktop. She has a blog that supports this, which talks about Docker containers on the desktop, basically running containers for every desktop application. Think of your browser like running Chrome, Firefox. Think of running things like VS Code, any kind of application you run on your OS. So in her example, she runs Chrome, Spotify, Gparted, Skype, and a bunch of other applications. And she gives examples of this. So you can see here's a Docker run command that runs Spotify. And if you're interested, she has all of this in GitHub under a Docker files repo. So each of these folders represent an application. You can see AWS CLI, the Azure CLI. You can see Chrome and Chromium is here as well. There's curl running in a container, Firefox, and a bunch of other applications, even Skype. She demonstrates a couple of key things. One thing is how to get a GUI working by mounting X11 into the container. She also shows how to get video calls working and how to get audio working. Now the key takeaway here is that this taught me exactly what a container actually is. A lot of people compare containers with VMs, and that's okay to do conceptually, because conceptually a VM is technically your operating system and your applications all packaged up as a virtual machine. And in Docker, we can also have our application, operating system, and everything packaged up as a container. But the more you dig about this, you actually find that containers are simply Linux processes. A process has a process ID, and when you run a Docker container on Linux, you'll notice that it's just a process with a process ID. It has a virtual file system tied to it, and there's a bunch of Linux kernel features which allows the process to see what it wants it to see. So it only has access to certain amounts of memory, certain amount of CPU, and it can only see the file system, which is virtual. But everything else about it is pretty much like a process. So at that time, I decided to containerize my entire laptop. So I moved to Linux, I installed Docker, and I created a ton of Docker files. And the cool thing is all I needed on my laptop was a terminal and Docker. And if I need an app like VS Code, I just type in the terminal VS Code. And because I have an alias set up, VS Code is actually aliased to a Docker run command. So for learning this, I decided to create my own My Desktop repo, which you can find on GitHub. If you go to this repo, you'll see there's a Docker files folder and all the apps that I run on Linux. The main ones that I use mostly is VS Code, Firefox, Chrome, Discord, and the rest are all command line tools. So whenever I get a new machine, all I need to do is install my OS, install Docker, and then download my bash rc file, and you can see all my commands that I run, like Chrome, is aliased to a Docker run command. So you can see all my applications here are all Docker run commands under the hood. And then over the years, working on Docker and Kubernetes most of the time, I realized that there was a lot of common tooling that I was always using, no matter the operating system. That is kubectl, Helm, JQ, curl, the Azure CLI, the Amazon CLI, and OpenSSL, and other Linux utilities. And because I was using these utilities all the time, I actually created another repo called kubetools, which is a Docker file that has all the Kubernetes tool sets and Linux toolkit that I basically use from a day-to-day basis. As I mentioned, things like kubectl, the Azure CLI, Helm, kubectx, kubeNS, and a bunch more other utilities. I find myself using this on a day-to-day basis, no matter the operating system. And when I want to run on Linux or I want to run on Windows, I don't want to have to go and make sure I have all these things installed. So most of the time when I want to run things like curl, or I want to even just access a Kubernetes cluster or run Linux bash scripts, all I do is run kubetools. You can see here I do Docker run. I mount my local file system into the container, and I mount things like the Azure folder for my Azure authentication, as well as my kube folder for my Kubernetes config. I go ahead and run that, and now I'm pretty much in a Linux container. You can even see I have the Linux terminal, and I can do things like curl, I can do things like JQ, I have access to things like the Azure CLI, I have access to kubectl, I have access to Helm, and I don't have to install these things. And this is running on Windows. So you can see that I have a lot of Linux utilities that just work on Windows inside of a container. So another huge contributing factor to portability that I don't see a lot of people mention or use or take advantage of is the browser. Since I run absolutely everything on Linux in a container, not all of that is possible on Windows. But because of browser-based applications, all I need on Windows is a terminal, I need VS Code, and the browser. All my favorite software and software that I use from a day-to-day basis run in the browser. If you think of Gmail, you think of things like Discord, Microsoft Teams, the whole Office suite, all of that runs in the browser these days. So I don't have a need to install any of it. Nowadays in the browser, we have Gmail, WhatsApp, Discord, all of the Google software, we have Outlook, Microsoft Teams, and the full Office 365 suite. And I very quickly realized a pattern. When I'm on Linux, I run everything in containers, and I run 90% of the things in the browser. And when I get to a Windows machine, I run mostly everything in the browser, and I end up just using my Linux tools on a container. So the OS does not matter anymore. What about things like Kubernetes? If you've watched a lot of my videos, you'll notice that I use a product called Kind. Kind is actually a tool that allows you to run a Kubernetes cluster in a lightweight Docker container. So again, you don't need Hyper-V for Windows, and you don't need a Linux OS, and you don't even need Minikube to get this to work. To get access to a Kubernetes cluster locally to do Kubernetes stuff like testing YAML and Helm charts and working on Kubernetes stuff, all I need to do is use Kind and say Kind create cluster, pass in the name of the cluster, what I want to call it, and then pass in the image. So I say I want to run Kubernetes 1.23. I go ahead and run that, and that'll just take a few seconds to spin up a Kubernetes cluster. And then to start working on that cluster, I just run my kube tools and I mount in my kube config file. So you can see if I run that, I can then immediately access my cluster by just running kubectl commands, as I'm in a Linux environment now. So my utilities have become very portable. So the beauty about Kind is that I can run multiple Kubernetes clusters side by side. If I need to test a Helm chart for a new version of Kubernetes and do upgrade planning, I can spin up a cluster within a few seconds, test the Helm chart and tear it down. I can even run multiple clusters side by side very easily with one line command. Now, just before we go through the main reason on why I run Windows, just a quick word from our sponsor who made this video possible. If you're familiar with Kubernetes, you probably think of YAML files, and when you think of YAML files, you think hundreds of files, thousands of lines of YAML, complex Helm charts and customized templates. And two things come to mind here: human errors and misconfiguration. Now, thankfully, there is a free and magical open source utility that helps us solve these challenges, and it's called Datree. Datree is a tiny command line app that helps us test our YAML files. It checks our YAML for broken YAML syntax, for valid Kubernetes schema, and also helps enforce and checks policies, and also helps manage these policies from a dashboard. You can even run Datree in your GitHub Action pipeline and prevent your precious pipeline from running if any YAML misconfiguration or policy issues are detected, as Datree supports multiple CI/CD workflows. Datree also ships in the form of a Kubernetes webhook, which can run Datree every time resources are applied to your cluster. This means Datree can run at every stage of our software delivery workflow. It can run checks locally in our CI pipeline, during deployments, and also run against resources that are already deployed, end to end. Datree also supports Helm, has native customized support, lots of official integrations, as well as community plugins like VS Code. This video is proudly sponsored by Datree. Remember to check out the link down below to my full Datree tutorial and take it for a spin. Now, over the years, and with everything I've just explained about portability, running things in containers and in the browser, I've essentially decoupled myself from the operating system, and I've reached a kind of parity point with Linux and Windows, where the operating system has become less relevant to me, because it doesn't matter whether I'm on Linux or Windows. I'm running all my apps in the browser. The first thing I do is open the browser, and then I run VS Code, and then I go straight to run everything in Docker. And since I mostly work on open source containers and Kubernetes, I'm always accessing cloud resources. So I'm always using kubectl, the Azure CLI, or the Amazon CLI, which all run inside of a container. So I have none of these tools installed on Windows regardless. My biasness for the operating system has really dropped and faded over the years because it's become less relevant. I used to be a heavy Windows user, and when Docker and Kubernetes came out, as I explained, I moved to Linux and I became a heavy Linux user. Linux will always be more superior if you want to learn learn about containers the way I did, and you really want to get your hands dirty. And then a number of years later, I realized that all of these things don't matter to me anymore because now I run everything in containers, everything has become portable, or it runs in the browser. So that means I can really run any OS that I want. So why Windows? The main reason I run Windows is purely for video editing and gaming. I have all my favorite games already installed on Windows, and I know Linux gaming is a thing, but I just don't have the time to get everything working on a Linux machine. Since I work in the tech space, I work on technology all day, all night. So when it's time to fire up a game, the last thing I want to deal with is technical issues. Also, the video editing software that I use only runs on Windows, and I've become quite accustomed to using it over the years. So there's no real reason for me to run any other operating system. Therefore, these days my day-to-day operating system is Windows, but I do have a Linux machine that I switch to every now and again, just to keep my skills going. So I hope this video gave away a couple of tips that you can apply in your DevOps day-to-day career, whether it be running things in containers or just learning Linux in general. And let me know down in the comments the day-to-day things that you struggle with, or any tips that you've come across over the years working in the DevOps career or in the technology space. And if you like the video, be sure to like and subscribe and hit the bell. And if you want to support the channel even further, be sure to check the Patreon link down below or hit the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.